Hello, everybody. Welcome to Toronto Enterprise DevOps User Group. This is the user group. If you're here for the first time, this is the user group based in Toronto, Ontario. That is the main focus of the user group is the DevOps technologies, processes, tools that are working inside the enterprise that are applicable, that can be used inside the enterprise. Okay, so we meet every second Thursday of the month, usually. And again, the topics vary depending on what's cool or what's available or what people want. So having said that, again, if there's a topic that you would like to speak on or hear about, please let us know, and we're gonna do our best to accommodate. We do have quite a few connections. One of them is Adin, who is presenting today on Terraform. But we'll get to that in a second. Before I start, I wanted to mention that this is the user group. And again, so we're here to facilitate. Please give us your feedback. Please let us know how would you like the group to evolve. The group is run by me and my colleague, David Lloyd, who is not here today because it's his birthday. So when he's gonna look at listen to this video, happy birthday! Wish you all the best. Again, too bad you're not with us, but you know what? It's a birthday. You get a day off. Today we're gonna do a second session on the infrastructure as code using Terraform, and then we're gonna have another one in a month, next year, I guess, January, second Thursday in January, and it's gonna be a more advanced session. After that, we have a session on Power Apps, the DevOps and Power Apps, and so that will be in February. We don't actually have anything scheduled in March, but again, it's March, it's too far away. If you have anything in mind please let us know. Having said, anyway, so without further ado, Adin, take away. It's all yours.
Awesome. Thanks, Max. Appreciate it. And welcome to everyone. Thank you for taking the time out today, this evening, or depending on where you're at in the world. So like Max said, this is the second iteration or the second level in the three-part series on infrastructure as code using Terraform. So myself, my name is Aidan Ermy. I work for Microsoft as a cloud solution architect specializing in Azure infrastructure, and I do have a lot of real-world hands-on experience with infrastructure as code, with DevOps, and specifically, obviously, in this topic, Terraform. So as we're going through it, feel free to put your questions in the chat there. I have that up on a second screen, so I'll try to keep an eye on that as well. Or if it's applicable, if it's a little bit too more complex, feel free to possibly come off mute and we can discuss it specific to the topics that we're discussing. Okay, so here's what we're going to be talking about today. We're going to go over some very brief, very quick basics because, again, this is the intermediate level of the presentation. We're assuming there's a level of understanding based on our previous presentation last month. Then we're going to get into the intermediate concepts around intermediate commands that we use, providers and lists and lifecycle and so forth, and then get into things like reusability, right? So how do we work with modules? How do we work with remote state and data sources and things like that? So beyond the basics, if you will. Later on, we will touch on a little bit with the pun on words of branching into DevOps, a little bit, not as deeply as the third version of the presentation is, but we're talking about some of the DevOps elements around Terraform that you need to keep in mind as you start to go down this path. And like always in my presentations of these series, we leave you with some resources to share and help you in your learning journey. So if you've seen the first version or the beginner edition of this presentation, these next few slides will look very similar, but I do update them every time I do this presentation. So as a bit of a level set if anyone's new here and wasn't able to attend the beginner edition or didn't view one of the recordings. Everyone usually has a question about, does Microsoft care about Terraform, because it seems to be in like competition to ARM, right? Our templating language for Azure specifically. But really, in a nutshell, we want to kind of share and showcase that Microsoft is definitely invested in Terraform. The Azure provider for Terraform, it's not solely owned by Microsoft, but we obviously quite heavily contribute to that provider in connection with the HashiCorp team and others that from the community that contribute to the provider. And case in point, the latest release is actually supposed to come out today. I don't believe it's been syndicated through the systems just yet. So as we run our demo examples, we'll see that we'll probably hit version 2.39 versus 2.40, but it's supposed to be released out into the wild today. And in that release, there's 82 enhancements and bug fixes. So effectively, and I forgot to change the month again, my apologies, but effectively every week, so 4 times in the month, the provider is updated and iterated on and released to the wild. So this is taking input from the Microsoft team. We have a dedicated team in Microsoft focused on Terraform and specifically the Azure provider for Terraform. HashiCorp has their own team, obviously, because it's their product, that's also dedicated there, and they work collectively together. So the provider is not solely the responsibility of Microsoft, but we heavily contribute to that. If you also go to the public registry, the module registry from HashiCorp for Terraform, there's a bunch of Terraform provider examples specific to Azure. So deploying a virtual network, deploying like scale sets or networking and so forth, all of that stuff we also contribute to. We don't solely own that because it's in the possession of HashiCorp, but again, Microsoft and the team that's dedicated and investing in Terraform is heavily contributing to those kind of real world scenarios, those battle tested modules to make them more whole or more complete and release them for people to be able to have confidence in leveraging them. The other quick thing, again, similar to what we've talked about in the first beginner edition of the presentation, everyone asks about roadmap, right? What's coming, when is it coming, and so forth. So if you go to this GitHub repo for the provider, the Azure specific provider, it has very publicly the roadmap and the milestones that we're striving to release. So you'll see that we're trying to release every week is roughly the kind of the marker that we try to hit, and you can actually go into those specific versions. So in this example, 2.40, and you can see what is going to be released, right? We have either new enhancements to properties that are now available to objects in Azure. We have updates to documentation. We have brand new resources, for example, that have been released and so forth. All of these things are publicly available to reference to see if, let's say, you're developing some Terraform templates and there's a gap where the provider doesn't have something, you can go here and actually check and see roughly when it's going to be released, if it's going to be in the next couple of weeks or so. So that kind of helps with your plan. Yeah, sure.
Sorry. So can the company take the Azure provider repo and fork it and extend it and make it like their own, so they can do like a custom provider and enforce that in Azure?
That's a really good question. I don't know the answer to that off the top of my head, but that's a really good question. My gut says probably not, because even though Microsoft is even like a heavy contributor to this, because it's in the possession of HashiCorp, well, all their stuff is open source, but I don't know if they have any restrictions because of that interoperability, right, between, say, cooperation with Microsoft and HashiCorp itself. Good question, though. Maybe ping me later on that. I can try to find an answer officially or otherwise.
Okay, we'll do. I kind of thinking yes, and just, but yeah, let's take it offline. Thank you.
Yeah, no, good question. Awesome, thank you. Okay, so now let's talk about a few of the highlights in the latest version of Terraform, which now is version 14. So we're still not up to that version 1.0 yet, but we're getting ever closer. There's definitely going to be a version 15. HashiCorp has stated that publicly, and they haven't stated anything beyond that, whether it's going to go from 15 to 1.0 or 15 to 16 and so forth. But some of the highlights from the latest version that's been released that we can leverage, and there's some value here, is around the output. So if you're familiar with Terraform and you go into your Terraform plan and apply, where we have all the output from what it's executing, even if something is not being changed or removed, it still is in that output. So depending on the size of your template, it can be rather long and large, that output that you're reading in the console. What they've changed now is to consolidate that and compress that. So it only shows the actual objects and the properties that are actually being changed as part of that execution. So it makes it a little bit more visually easy to be able to kind of read and see it. So I see Anthony put in the chat, yes, 14.2 did come out, I believe came out today or yesterday. Yep. The other features in 14 is the sensitive input variables. So you'll see in the example on the right where we have a variable and we have this sensitive equals true. What this does is it ensures that the output of this variable, this value that's generated or created, is not output to the console. It'll kind of effectively redact it, right? It'll say sensitive value. However, it does not mean that that sensitive value is not in the state file. It still will be in the state file. So kind of keep that in the back of your mind. Another really nice feature is this dependency lock file. When you run Terraform init, it creates a brand new file, and you see the example below where it actually effectively records the exact version of the providers it used with that execution and the hashes to validate that. The reason why that's beneficial is that if you're working as a team, that way, if someone else is executing the Terraform plan and they perhaps mistakenly upgraded to a new version of Terraform when the rest of the team wasn't at the same level, right? It will check this and ensure that, oh, well, you're not using 2.39 for the Azure provider, you're using 2.4, that doesn't match with what I see as a dependency, it won't let it continue. So that's another kind of a protection. If you remember from our first presentation where we talked about version pinning, same thing, but this adds an extra layer to help protect when you work as a team with more than one person. And we have finally some additional conditions with our variable validation. So we got this new feature in version 13 with some conditions in variables, but now they're continuing to expand and enhance those so that we can have all true, any true, kind of some logic even within the condition, as well as having multiple conditions that a variable has to match against. So we see a lot more robustness and flexibility to make like a packaged solution and hand it to someone to use. And as an end user experience, we're enhancing that interaction, right? Are they putting in the right thing? Is it in the right format? You know, there's different logic there. So really nice to kind of see that coming to fruition. Okay, so here's the quick basics, just to level set in case you weren't able to attend the beginner edition or weren't able to watch the recording. We do have a link for that for you to catch up on that later. But effectively, we're assuming you understand the standard commands, the basic commands, Terraform init to initialize the directory you're in, Terraform plan for it to read your template file and see, compare it to the existing state file and environment to see what it needs to change to align that. Apply is executing that plan, and destroy, self-explanatory, removes what you've deployed. Within the Terraform template construct, right, we've got the resource type. inclusive of the provider that you're targeting and the resource type itself, specific to the, to the provider. So in this case, in this example, like a resource group for Azure, a name reference, which is specific to Terraform, versus the properties within that resource that's specific to the type of resource you're deploying. In our beginner edition, we also covered things like the file structure, right, with having backends, having providers, having variables and outputs, basically standard kind of stuff. So again, if you haven't watched the beginner one, do feel free to ask questions as we go, but we might defer you to go back to the beginner edition to kind of cover some of those basics. Okay, on to the intermediate stuff. So firstly, here are some commands that I consider to be more intermediate. So the next kind of step up from the basic, init, apply, plan and destroy. So the first one is Terraform FMT, short for format. This is used to format your Terraform templates in a consistent way. And when you're working as a team, think of it a little bit kind of like linting, right? Where you want things to align to a certain style and so forth, and you want things to be consistent. Doing this, aligns all of the spacing, all the the tabs and so forth, so it's more consistent. Ultimately, when you work as a team, you don't want to know that, okay, person A wrote this file and person B wrote that file, that template file. Ultimately, you want that to be universally the same and aligned to a specific formatting and style standard. So there's some default stuff out of the box for that, but you can also customize that based on your specific team's needs. Terraform Graph is to help you to visualize what's in the state file or what's going to be executed against a plan. It's not a really kind of like a pretty diagram, to be blunt. It's not like it looks like Visio and it's colorful and so forth. It's just effectively black and white blocks and showing the interconnectivity of the graph, effectively showing the order that things are going to be executed in, but it still helps from a visual standpoint for sure. Terraform Show allows us to be able to see the state file or the plan file in a human readable way. So if you were to go and look at an actual state file, you'll see it's a little bit more robust, right? It's a little bit more XML-y a little bit, right? To be able to kind of navigate through to figure out where's the property, where's the resource that I need to look at specifically. Terraform Show kind of gets rid of some of that. Sorry.
Quick question. So the graph, when it generates something, is it like in an image? What kind of format is it?
Yeah, so that you can use to generate like a dot file, DOT file, and then you can pipe the DOT file into to an SVG, like to create an actual image file of the resources specific to the file your template that you're building. Terraform Validate is Terraform's way to kind of check the syntax of your template. And we're going to come back to that a little bit later with a different example. But when you run Terraform init as your starting point, it actually runs validate additionally behind the scenes. It doesn't show in the output that it's running Terraform validate, but as part of the Terraform init process, it does run the validation check. Finally, Terraform taint allows you to specifically target a resource and say, this needs to be destroyed and recreated. Now, why would you want to do that? Think about the example where maybe your Terraform template is building a virtual machine or some environment, but as part of that execution, you want to execute something within that resource. So think about like a chef cookbook, right? Or a chef recipe, right? For configuration as code. So the VM itself is fine, but you don't need to retest, say, your recipe or cookbook. Well, running Terraform templates won't explicitly do that because that's a separate tool and that's within the system and the VM is already created and so forth. So you can mark a resource as tainted So the next time you run Terraform apply, it knows, okay, I need to destroy this resource first and then recreate it as part of the next execution. So I see there's a question is, can you untaint resources? I believe, yes, you can. Yeah. I don't recall like if it's just untaint, as simple as putting untaint versus just taint. But yeah, I believe you can do both directions. Yeah. Okay, let's talk about alternative or non-default providers. In the example on the right, this, in your code, you have a provider saying, I'm targeting Azure, or I'm targeting AWS or Google, whatever, on-prem, whatever your template is supposed to do. And we see in the default provider, that first one, we are setting the location to Canada Central as effectively our default location. But you can use additional providers to be able to simultaneously deploy to different environments or different areas in this context, in this example, at the same time. So why would you want to do that? So think about this. One example is for a project that I did for a customer where we are building global networking components with a hub and spoke topology. So the core services, prod and non-prod, VNets, and then there's peering and everything together and so forth. And we're deploying that block in every Azure region in a global capacity. So in 8 different regions across Azure. So you can execute all of those templates one by one for one specific location. So in this example, Canada Central. Or you could have in your template provider for Canada Central and then an alternative aliased provider. So notice that the first one is not aliased, but the second one is an aliased provider that you can then target, say, to Canada East, and then deploy the template collectively simultaneously as one execution and tell Terraform, deploy this resource in Canada Central and this resource in Canada East. Now, however, that gets into a little bit of complexity because either you're going to be duplicating your resource declaration in your template, or you're going to have to somehow create a map or a loop through that resource, and first pass would target the default provider and the second pass would target the aliased, the alternative provider. Gets a little complicated. It is possible to do. Have I seen it in the wild? A little bit, but not a lot. So it depends on the scenario that you're targeting, if it's applicable. But know that you can do this. So you have this flexibility that you can say this resource must be in a different region, regardless of wherever the default location might be, as an example. So we talked about a list a little bit, so let's kind of get into that. In Terraform, we have different collection types like maps and lists and sets. This is kind of like an array, ultimately speaking, right? A list is a very simple list, it's sequential. A map is a little bit more like an array, right? A multifaceted array where you have a property, the first property and the second property of the object. How I've seen this being used in the wild and how I've actually used it myself is this example on the right and on the bottom. On the right, we have a map that has the Azure region specific to where this customer wanted to deploy. And we have a short form of that name. So we called it a variable, made it a map, and said, here's how it correlates. Then we can reference that variable, that map, and say, give me effectively the variable location. So I'm taking that's passed in from the execution, and go and look up that location in the list, and then return back to me the short form that I've designated here, and use that to build a naming convention for the resources being deployed. So in this example here on the bottom, we're using the location where we're targeting our deployment, which Azure needs specifically, and the resources themselves need as execution, but then using that I can use that to create a naming convention for this resource. So this is the production network. So in front of it, it would say, if it's Canada Central, it would be CAC-production network. So that's how I've seen it actually being used in real world examples. So lots of flexibility around these. You can even kind of combine things together. Gets a little complicated, but the fact that you can leverage it in this example as a naming construct is actually quite helpful, right? So if your customers have a naming convention based on resource location and they don't want to have like a full, like Canada Central fully spelled out, for example, because there's some name length restrictions for certain resources like storage accounts and so forth, you can use this to build a bit of a naming construct. So it's actually quite useful.
Do you know which version these things were introduced in? Have these things been in Terraform forever, basically, or not?
The list and map and so forth, or like
Right.
all of this. So a
Yep.
lot of this, yeah, the stuff that I'm covering today has been in there for, dare I say, I don't want to say forever, because I started working with it maybe 3 or 4 years ago or so. So back in version 11 dot whatever, and it was there at that time, right? That's where I'm pulling some examples that far back that are still valid today. So it's only maybe the newer feature sets, right, in the version 14, version 13, with some of the stuff around variable conditions and things like that, would be specific to the version, the targeted version. Good question, though.
Thank you.
Yep, no problem. Okay, loops and conditionals, right? If we're kind of programmers, developers, this is common sense, right? You loop over stuff. You have conditions around stuff. Makes kind of sense. In Terraform, same type of thing. You can have counts, right? It's a whole number. It's an integer type of thing to say how many of a resource do you want to create. You can have for loops or for each loops and things like that. You can have Boolean expressions, right? So you can say only create this if X equals Y. So the example that I have at the bottom is also one that I've used with a customer where, as part of the template to deploy a virtual machine, not all virtual machines may need a data disk or the same number of data disks. So to be able to, instead of like building multiple templates that effectively do the same thing, but are different just for the data disk piece, we just modify the data disk code to say, pass me the variable of how many data disks they need. And with that line there, what that basically means is if it's greater than 0, then we're going to create that many data disks. But if it's not, effectively, we're creating 0. And when Terraform sees 0 in the count for a resource, it ignores it. It basically does not create that resource at all. So another nice piece that we'll get into a little bit is this count and for each methodology originally was only available for the actual resources in the template that you're building, that you're coding in, but you could not use them with modules, which we'll touch on shortly. Thankfully, in version 13, so one version ago, HashiCorp released module support for count and for each, which allows us to pass in a count into a module that then goes and does a bunch of work and returns the results. We can effectively loop over that versus having to call the module separate individual instance times throughout our code. So that was a nice welcome feature for version 13. Up until then, it was a little bit more difficult to work with. Okay, now let's talk about Lifecycle. This piece of code tells Terraform, specific to the resource that you put it inside, what it should and shouldn't do. We have 3 options, a little bit self-explanatory with the labeling of the names, right? Create before destroy. So effectively, before you destroy a resource, make sure you create its replacement first, right? Maybe there's a requirement it's a VM in a scale set. Maybe it's a node in a AKS, a Kubernetes pool, right? Something like that, where you want to make sure you're not taking down the entire system, the entire app, because you're removing that one object just to recreate it. You want to create the first one, the replacement first, and once that's validated or verified, then Terraform, go ahead and destroy this resource. Prevent destroy does something a little bit similar, with some exceptions though. Prevent destroy, obviously, name explains, it's going to block you or anyone from accidentally destroying an object, right? However, in your code, if you have a resource block for a database, for example, or some other component, and you have this prevent destroy, that's great, that's a good protection. But if someone were to delete the actual code block itself that defines and declares that resource or that database as an example, prevent destroy will not prevent that from actually being destroyed, because Terraform will read the template and say, hey, you said you don't need this resource anymore because you've deleted it from your template, and that now doesn't match what I see as, in production or in the wild or live according to the state file. That means I can remove it. So it's not a catch-all, but it does add a layer of protection from the context of automation and working as a team and so forth. The final one, ignore changes, a little bit self-explanatory, but when would you actually need it? A really good example with this is that shared management context, right? So let's say you're using Terraform to build your entire environment in Azure. So good job. So it's deployed, everything's great. Now, if you're familiar with Azure, we have certain tools like Security Center or Azure Policy, which will periodically scan or check the target systems, the target environments, and depending on what you've set for your policy, Azure Policy will actually go and change the resource. So maybe it's missing a tag, maybe it has something it shouldn't have, and the Azure Policy will just go and make that modification if you're using like deploy if not exist, for example, or append. The problem is if Azure Policy is doing that from a governance perspective in the environment, now those changes that have been made do not match what's in the Terraform template or the state file. And so when Terraform goes to run again, it's going to see, well, that A doesn't match B, so it's going to overrule or overwrite whatever changes have been made outside of Terraform. And that might not be what you want to do, depending on your scenario. So having something like ignore changes, and in the example here, saying ignore changes to, say, the tags property, because we know from a governance perspective, we're going to apply Azure Policy to the environment, and we're going to ensure every resource has a cost center, it has like an owner so we know who to contact, it has an environment tag, whatever. If someone were to miss that, then at least from a governance perspective, it's going to be applied, and it's not going to break your DevOps and your infrastructure as code process while you're using Terraform. Okay, let's talk about reusability so we don't reinvent or recode the wheel. So when we write our Terraform templates, right, we have our files in our directory, as we see in this example here, with ExpressRoute, and also networking for a hub and spoke topology. Now, a module in Terraform is effectively anything within a directory. So in this example, all of those files under the hub directory or folder all comprise a single module as far as Terraform is concerned. So when you're executing against that module, Terraform will take all of those files listed there and effectively merge them together from a computer perspective as one Terraform file. we as humans will split them out so it's a little bit easier to track where certain resources or properties or variables are kept, so we know where to go to fix or modify something, right? We have an outputs file, we have a variables file, and then we have other files that we work with. But from a Terraform perspective, everything in that folder is effectively a module. In the example code at the top, we're calling our express route module. So we're calling the circuit specifically. So you can't just call maybe the express route at the high level because there's no files in there, there's just folders. It doesn't traverse the hierarchy, the directory, right? It's going to look for actual Terraform files to execute against. So you need to directly point it to that, to a directory that has a TF file. I see there's a question from Alan. What's the advantage of using Terraform to deploy VMs on vSphere cluster environments versus just vSphere templates? So good question. So a lot of organizations like to use Terraform because it is multi-cloud, but then even from an on-prem perspective, like multi-provider. So you as the operations team or the development team or the security team, whomever, you have one language to learn, which is HCL, right? Some of this is covered in the beginner edition. So you learn this language. Now you still have to write your templates specifically targeted to what you're targeting against. So is it Azure, is it AWS, is it VMware, whatever, but it means you don't have to go and say learn ARM for Terraform, or sorry, ARM for Azure. You don't have to learn cloud, is it Cloud Formation or Cloud Foundation? I forget, I get them mixed up, for AWS or whatever the Google Cloud one is. You don't have to learn the specific scripting language or for VMware or PowerShell or Bash, right? You can still focus on the language as a whole and just learn the correct provider that you need to target and the properties and so forth. So it's not, I'm not going to say one's better than the other. It's subjective to what you want to do and what you as an organization want to focus on. But good question. In the modules, just to call out a couple other things here, notice that you can call other modules. So like a child dependency module. So as an example, let's say I wanted to deploy the entire express route package, if you will. So deploy the circuit, deploy the connection, and create the peering. Now, if you're familiar with express route, that's not really how you would do it because there's actual humans involved with, from a provider perspective, from an express route ISP, right, to enable something on their end, and then it comes back and tells express route it's okay. But if you wanted to effectively daisy chain those modules together, you can do that. You can see how in the top part of the code it says module, whatever I want to call it, and source tells Terraform where are my Terraform files that I'm going to execute against. And then underneath that, we are passing variables into those modules. Same thing like when we author Terraform. What are the variables and parameters that we need? What is that module looking for? And then that's what we need to pass into the module for it to then be able to go and execute and then return the results. Okay. All right, let's talk about data sources. Now we're kind of getting into more of a shared type of responsibility and environment. So a good example here will be, let's say, let's put on the hat of like the networking team. And the networking team has authored all of their Terraform templates to build all of the networking pieces, the VNet peering, express route connections, whatever, specific to the environment. They have the responsibility and ownership to manage those templates that control the networking layer. Now, the development team, the app dev team comes along, right? And they need to deploy their applications, whether it's VMs, whether it's like serverless functions, whatever it might be, but you need to target a specific subnet that you need to deploy into. Well, you're not going to author or re-author Terraform templates for the network because that already exists. but you want to reference something that already exists from a Terraform perspective. This is where data sources, and on the next slide, remote state comes into play. Data sources tells Terraform, go look up this existing resource. It's already created, regardless if it was created with Terraform or not. It doesn't care. Go look it up and effectively grab that object so that we can use that and reference its properties in some other execution that I want to work against. This is how you effectively can kind of share that responsibility between different teams while everyone is still working in infrastructure as code, but it's not like it's one giant pool of templates. There's some separation, right? Now with remote state, kind of carrying along that discussion, that's another way that you can reference something that already exists that someone else has created through Terraform. If the networking team is using a remote backend, which is something we cover in the beginner edition of the presentations, whether it's on Terraform Cloud, whether it's on like a Azure storage account, wherever it might be, right? You can take your template as, say, the app dev team, and you're trying to target the state file of the networking team's resources. So you're not just saying, go look up this VNet specifically, but you're saying, go read from that state file that contains effectively what's live from a networking team perspective. Why that's a better route to go is if the networking team were to make any changes or modifications, you wouldn't necessarily know about it just by calling a data resource and referencing saying, go get the VNet. But if you're referencing the state file that is the source of truth from Terraform, what's live in the world, then that gives you much more flexibility to reference anything that is output into that state file, even though you didn't create the templates that created that specific state file. So that's where, again, we have that shared responsibility where we're able to access different bits of data outside of just our bubble of here's our module or here's what we are building through Terraform. Now, a key point with remote state is that you need to have outputs appropriately set. So if you remember from the beginner edition of the presentation, you use outputs in Terraform to tell it what are the values, what are the property values that you want to effectively surface or expose so that that can be used either by yourself in some other template or by someone else in this context with a remote state reference. If you don't have an output for, say, the virtual network ID or the subnet ID or something that someone would actually need as part of their code execution, then they're not going to be able to reference it and use it. Okay, here's a little bit of bonus before we get into the demo. As I'm talking through this, watch this little kind of graphic example video here. Because if you're not familiar with TFLint, it's part of the GitHub superlinter, and it's a really awesome tool. Basically, remember how we were talking about Terraform validate? And don't worry, this little video graphic thing should loop through if it gets to the end, if you missed part of it. Terraform validate just validates the syntax of Terraform itself. It does not validate against a provider-specific issue. TFLint does. So in this example, it's showing AWS, which is fine. The instance type is wrong. It's an invalid type. Terraform validate says, hey, it looks good. Okay. But when they go to apply it, that's when it's caught by the provider saying, oh, that's not a valid instance type after you're doing Terraform apply, right? We'll see it kind of loop through. And there you get the error. So to kind of prevent that, where you might get partial resource creation and there's going to be some cleanup and stuff like that, TFLint will tell you there's an invalid reference before you even execute that template. So that's something good to think of from a DevOps perspective, right? As part of that workflow, being able to execute against the TFLinter specifically, because it checks specific to the provider, right? The best practices against the provider and not just Terraform as a language itself. And it does support all three clouds. Now, obviously, from the numbers at the bottom, they started with AWS, which is totally fine. There's over 700 rules that it validates against. Great for that. Azure is something that they're currently in the middle of working on. So there's a little bit less than 300 rules, and things are continuing to be added there. And then Google is the third one that they've gotten around to. I think the last time I checked, there was only one rule for GCP. So that's still in a progress, of course, and everything is always in motion or in flux, but it's a good tool to think about from a code commit, right? A PR into a repo perspective, being able to execute the GitHub superlinter or just TFLint specifically inside of that as part of that validation before any templates are actually run through the Terraform apply process. Okay, let's stop talking and let's actually see some of this in action. So just to double check that I can see my code. I think I can. Just let me know if maybe if it doesn't show up, but I think from what I can see, it's up, so it should be good. Okay, so here's some sample code where I have, if I collapse this a little bit for a moment, I have a module for hub, like we saw in the screenshot there, right? For a hub VNet, it's making NSGs. It has rules in here for the NSGs. We have outputs that come from it and so forth. Standard kind of Terraform practice. Same thing for, I'm just going to kill that for a sec. Same thing for Spoke, for prod and non-prod. Similar kind of concept, right? There's a VNet, there's subnets inside of there. This is like a three-tier kind of simple process, right? Web versus app versus data, and NSGs that wrap around all that good stuff. So these in themselves are individual modules. So this is the hub module, this is the non-prod Spoke, the prod Spoke, and the VNet peering module itself as well. We have a separate location that we are actually executing our deployments from. So we can keep our code that is actually defining the resource separate from the code that's triggering the deployment. That way we can iterate on either one of them without any kind of conflict. So within this directory here, I have a hub deploy template. And really all it is standard Terraform reference stuff, right? Standard provider for Azure specific reference. And then further down, we are calling the shared services module. So that's just whatever I labeled it as. However, I'm telling it this is where it lives. So up the stack, down the stack into this hub directory, this is where all my Terraform files it's going to look for that Terraform execution of this module. If we look at the variables for this module, we see environment, cost center, right? These are going to be used for tagging, address spaces, whatever we need to define. And those are what needs to be passed into that module, right? So this on the right-hand side is the variables within this execution space. I just named them the same so it was easy to keep track of everything. But on the left has to correlate to the name, the explicit name of the variable that the module itself is looking for. Okay, it's easy to keep them together, universal, right? The same, so it makes sense when you're working through it. So we are effectively just going to do one call, and that's going to call this module. These are the parameters of the values that we're passing through. Go and build me my hub. So we're going to go down to networking deployments, and then hub deploy. Okay, let me just make that a bit bigger. We'll go Terraform init. So notice in this hub directory, we got the .terraform file as part of the initialization. It does not exist in the hub. It's calling the hub, but the execution pieces like the locking of the state file stuff, all of that sits in this directory where we're calling the Terraform deployment from. So notice here again, right, we're saying, oh, .40 did come out. Nice. Last time I did this, even though it was released on the Thursday, it wasn't just yet out in the wild. So good to see. And now if we go Terraform plan, oops, my bad. I forgot to do something a little bit better. So sorry, Terraform plan, and then we're going to go var file, not fail, equals, and we're going to say hub east us.tf vars, and then we're going to say out, and then we're going to say east hub.plan. Okay, so now it's going to use this variable file. I'll minimize this slightly to take a look at that. This is where I can execute all my templates from this one directory, but use different values as the variables being passed in. So I'm still executing the same module, that hub module, but I'm passing different parameters effectively in at the time of execution. So you can keep things compartmentalized, right? Okay, and so it says we're going to create 17 resources, so that's great. Go Terraform apply, and we go east hub.plan. We'll say auto approve, so that, oh, I don't think it likes auto approve. My bad. There we go. There we go. Okay, so one thing you'll also notice as this is executing, I am using just local state. If we go back to the code real quick on the deploy execution, you'll see up here, right? I'm not using any backend just for simplicity. Normally, obviously, you'd use storage account or Terraform Cloud or whatever. Just for simplicity for the demo, I'm just keeping it all local, so it's a little bit faster to execute. So here it's going through, it's building our stuff, it's taking the variables that we've passed through here, and we can have a separate TFVars file for each of the regions so that we know very simply, very easily, this is the values that are being used for East US versus West US or whatnot. That makes it a little bit more easy from a source control perspective, right? So you can see what did we actually deploy versus sending stuff or putting stuff in on the command line itself. So while this is executing, if we go over to the portal and take a look at our resource group, make sure the portal looks up. Yep. So we see here is our shared services resource group. We've got tags that are applied based on it. We've got stuff, everything's deployed in East US. We've got virtual networks and NSGs. If we go into the virtual network, if it's not quite done yet, we'll see. We have the subnets created. It hasn't associated the NSG just yet because it's still working, and there it goes. There's the domain controller NSG applied to the subnet, and then that should be done. Boom. Okay. So you can rerun the same execution for East and West and split that up while that's still all contained within the same directory, in this case for context. Now, after we run the hub, we can run the spoke, and then after we run the spoke, we can run the peering. So I'm not going to run all of that just in the interest of time, but I am going to show you the data pieces in the spoke, or sorry, in the peering. So when we're executing the peering, if you're familiar with VNet peering in Azure, you need it has to be making changes on the VNet on both sides. So from, let's say, core to prod, right? You need to initiate the peering from core to prod, and then once that transaction is complete, back from prod to core to finalize that actual peering. You can't do it all simultaneously at the same time. You have to wait for the operations to finish. This is kind of where calling multiple modules comes into play, and you want to control the order of things so that it doesn't step over itself and have a partially failed deployment. So in this code, if I just pull this down a little bit, we have a module for VNet peering, and we're passing in quite a lot of stuff. We're passing in information about the hub VNet, we're passing information about the production VNet, and then the non-production VNet, because it's going to kind of do like a 2 or 3-way thing. It's going to go hub to prod and hub to non-prod, and it's got to go both ways at the same to create the peering. Notice we have depends on that as commented out. This was not yet supported at the time. This is also something that's now newly supported, I think, in version 13, but I'm not sure if it's fully implemented. Maybe it was just starting to kind of roll out for functionality. If we look at the code for the peering, we see here that we start with hub to prod peering. So it goes hub to prod, establish that connection. After that's done, we need to go back from prod to hub to finish it, to make it enabled. So notice in the actual module code for the peering, we have this depends on here. This is telling Terraform, when you're executing this module, this code, do not execute this specific resource until this specific one is finished. So this is how we can daisy chain pieces together as part of a module construct, right? As pieces of the blocks come together, because without this line here, if that was commented out, Terraform would try to execute both of these at the same time because it doesn't understand. There's no implicit dependency telling it there's a reliance on the first one to finish first, right? You can't do it simultaneously. That's a limitation currently today with the VNet peering in Azure. So by putting this in place, and you'll see that this is all along the same way, hub to non-prod and non-prod back to hub. And you can kind of piece that all together down the stack. Now, I've used this in a real world example for a real world customer, and it was actually even far more complex because we were deploying this hub and spoke topology in each region, so Canada Central and Canada East, and we had this peering between hub and prod and hub and non-prod, but then we had a mesh, kind of like a service mesh, a mesh network between two different regions. So hub to hub, and then hub central to prod east, and then and vice versa. So it gets a little bit complex. So you see that it would require a lot of depends on to make sure it goes in the right order to ensure that the executions aren't kind of stepping on each other while they're waiting for the different pieces to finish. Okay, time check, we're at 7. Let's quickly go back just to finish up some of the content here, and we can continue where if we want to kind of follow up afterwards for any questions or see more demo, whatever we want to do. Okay, looks like it's up, so that's good. So now let's, pun intended, let's branch into DevOps, right? So we've talked about reusability, modules, referencing existing stuff, either through data sources or remote state. Now, what is the natural step or progression is, of course, pulling this together in a more DevOps type of fashion. So there's two things around Terraform when it comes to DevOps that you need to be aware of. The first is workspaces. And this is a little confusing because there are two versions or two different contexts of workspaces. There's a workspace from the CLI perspective, and there's a separate workspace context from a Terraform Cloud perspective. So when you're working with, like I was on the command line there, Terraform apply, Terraform init, all that, you could work with a workspace there to have a separation of state files, right? Even within the same area that you're operating. But then that's only if you're working locally, right? If you're working as a team, and even if you're not working as a team, it's better to kind of work towards using a remote state store like storage account, Terraform Cloud, whatever, because then everyone can reference that remote location to validate against for their template execution. But in the documentation, it's not super clear if you look up Terraform Workspaces, whether it's talking about the Terraform CLI or whether it's talking about Terraform Cloud, because effectively they use the same term in both perspectives. So keep that in mind if you're doing any like research or trying to look up some documentation around that. Double check what the documentation is referring to so that you don't get, you're not referencing the wrong thing. Okay, Terraform Cloud. So we talked about this a little bit. This is basically HashiCorp's shared state store, right? Instead of keeping the state locally on my system, it's like putting it in a storage account. It's like, go keep the state in this other location, and then others on the team can reference the same remote back end when they're doing their execution, so that if one person makes a change to an environment, that's reflected in the state, and that same state file is being used for the next person on the team that might be referencing that same type of resource or that same object and the changes that have happened, right? That's the best practice to kind of get into the habit to be at least comfortable and familiar with remote state. And Terraform Cloud is just one of the options available. There is a free version of that, you know, with certain limitations. There's paid tiers within there that gives you additional value around like governance. There's actually a really neat feature in the governance tier where it will run your Terraform template and then tell you before it executes, tell you how much is that going to cost you in the cloud before you actually execute and build that environment. So that's really neat. There's a cost to that. I do have a video on my YouTube channel about that specific feature set. If you want to kind of take a look and see how that reacts. So pretty neat, depending on what your team is doing, what your organization is doing, if they want to look at Terraform Cloud. Okay, now let's talk about some resources. Oh, there's a quick question. Sorry, missed that, Simon. Does Terraform Cloud have a timeout in deployment, or is it defined by the developer? Good question. I believe there is a timeout. I don't recall exactly where that is set. I don't remember it being anywhere that you can actually explicitly say, oh, don't run this template, say, like longer than 5 minutes, for example, because then you know it's not working. I don't recall seeing a spot that you can explicitly state that for the execution, but I'll make a note of that to look that up, because I go into Terraform Cloud, among other things, in the next presentation, in the advanced version, which is all the DevOps stuff, where I actually compare Azure DevOps pipelines, GitHub Actions, and Terraform Cloud from a DevOps execution perspective. So I don't recall seeing that, but I'll make a mental note to try to find that out for that presentation for you. Okay, so if you're familiar with my presentations on Terraform, I do provide a slide or two of some resource links that you can help you along in your Terraform learning process. Also, each presentation has a different set of links, so it's not like it's just a rehash or repeat of the exact same resources from the beginner. I make them specific to the topic, right? Beginner edition, intermediate, and then the advanced stuff. The only thing that's a repeat here is the first one is my personal curated list of resources. So as I've been learning and working with Terraform over the years, I have made a personal list of the resources that I have personally found most effective in learning, because there's so many resources out there, right? You look up Terraform, and how do you know what video, what book, what course is worth your time? What's, has real good quality? If you know me personally, Max knows me personally, a few of you on the call might know me personally. I read a lot, and so I put reviews of books that I've read on Terraform, as well as saying these are the kind of go-to books that I think are worth your time if you're getting started or where you are in your journey. The other thing just to call attention to is if you're using Visual Studio Code to create your templates like I was, there's 2 extensions I would recommend. The first one is the Azure Terraform extension by Microsoft, so it's the more Azure specific stuff. And then the Terraform extension, which originally was created by Mikhail, but HashiCorp actually took over ownership of that, which is really cool because they've released a few changes and improvements to it. It has a language engine where it will build code blocks for you. It'll tell you what properties are optional or required. Are they, what are they, a string? Are they a Boolean? Whatever. Really nice extension. It's not feature complete. They're still working on it, but from what I've seen since the original, I'll call it the original release after HashiCorp took ownership of the extension, there's some really good potential, and it's going to be a really helpful tool in creating your Terraform templates. I also have on my GitHub repo some examples, what I call real world, so actual example code that I've used, obviously scrubbed and changed from customers. So the example for the express route stuff is up there. The example for the hub and spoke and VNet peering stuff is up there. There's a whole bunch of stuff up there. Examples for governance, right? So Azure policies, so creating a policy definition, creating a policy set, so an initiative, multiple policies combined, and then making that assignment. Things like management group structure. There's some examples up there that I've used in the real world that you can definitely leverage by all means for what you're doing. Some other quick list of resources. There's some things around quick start templates from an Azure perspective. If you're used to the Azure quick start templates, we have a Terraform version of that that you can kind of get started with. Hands-on labs, other things like how to kind of work with the more intermediate stuff like the looping and the functions and the expressions. One thing I like in this list is that last one called TerraGoat. If you're not familiar with TerraGoat, it is actually designed purposefully to be vulnerable and wrong and broken so that you can use that as a learning project to learn Terraform specifically. So run it through TFLint, see what it says is wrong, what's a bad practice versus a best practice, and really kind of understand it really well. And I personally like it because I personally have actually contributed to that project because they originally only wrote it for AWS and they were just starting out in considering doing it for Azure. So I worked with their team, with Bridge Crew, and helped author and test that specific version for Azure. So definitely take a look at that from a learning perspective. Finally, one other slide here around certification, because everyone likes certifications. We like shiny badges because it looks really cool. There are a few resources that we have available. There's the first one is, obviously I'm a little bit biased, I co-authored a cert prep guide with another MVP, Ned Belevance. We wrote this guide for the Terraform certification exam based on our personal real world experience using Terraform and then relating that back to the exam objectives. So that's up on LeanPub if you want to take a look at that. Lots of people have had good positive comments that they've said it's been helpful. So that's good to hear. And then of course, HashiCorp now officially has study guides, exam reviews, and sample questions. We authored our guide before any of that existed, and unofficially, right, HashiCorp knows that we wrote this guide before they wrote their stuff, and that's fine. It's all good, above board. So it's just another resource you can take a look at. And with that, this is my final slide. This is who I am. I like to leave this to the end, so hopefully at this point, I've earned the value of you connecting with me or reaching out or wanting to connect with me. This is who I am. This is what I do. And this is how you can get a hold of me, right? So Twitter, LinkedIn, my GitHub repo, my YouTube channel with the Terraform videos, whatever you kind of want. Feel free to connect or reach out. And then also on my blog there, I have, again, real world articles that I've written about my experience with Terraform. So it's not all, everything is beautiful and great, like a marketing thing. It's, hey, I ran into this issue, and it's actually a problem with the provider, or it's a problem with Terraform. It's a gotcha you want to be aware of type of thing. So learn from other people's kind of pain in certain contexts, because it will help you kind of be that much further ahead when you're starting down your journey or your path. And with that, I will stop talking momentarily to take a drink and turn it over to Max, and then I will stick on if there's questions or if there's anything else people want me to show or so forth.
Thank you very much, sir. Again, excellent. Does anybody have any questions? Do you want to ask?
Yeah, I've got a question.
Go ahead.
Are your slides available online anywhere?
The slides? Yeah, so I don't know if Max wants to post them anywhere, like if you, for specific to the user group, that's totally fine. I can send you a copy. If not, I do also have a copy up on SlideShare.
Do you mind putting it on the, like a meetup on the post, like in a discussion?
Oh, sure.
Just put the link to your thing, and that'll be all. That way, I'm not the middleman, right?
Okay, yeah, no problem. I'll put it up there after this, after the presentation.
Thank you. Any other questions? We will record the video. Well, we already record the video. I will post it on the YouTube channel as well. And again, thank you very much for attending. Thank you, Irene, for presenting. And I'll see you in the next year in the third and final session on Terraform infrastructure as code. Thanks, everybody. Is there questions, or just 1 second? I just want to go. No, it's just thank you. All right, so thank you again, and have a good the rest of the evening, and I will see you next year. So Happy New Year, Merry Christmas. Thanks, everybody.
Thanks, everyone.
Bye.